We are going to finish 2.8C, linear pairs, bisectors, and right angles, and doing proofs with those. So if we look at number 5, the given isn't completely filled in because we look at the triangle here. What do angle 2 plus angle 3 plus angle 4 add up to? Well, this is what we call triangle sum. They always add up to 180 degrees. So that was just something we wanted to talk about as we got started here. So the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180. That is, of course, our given. There's no way to mark that in the triangle. It's understood to be the sum of 180. And we want to prove that 1 equals 3 plus 4. 1 equals 3 plus 4. And so we're kind of stuck. We don't have any wordy statements. And if we're working through we the people eat pizza, we put the given in. We have no wordy statements. We want to go to the picture. Do we see angle addition, linear pair postulate, or vertical angles are congruent? And we do have a linear pair postulate going on here. So we can say the measure of angle 1 plus the measure of angle 2 equals 180. That's linear pair postulate. And now we can move on down to step 4 where it says equal to the same thing. Do we have two things equal to the same thing, either equal to 180, 90, or the same angle? Let's look. Well, both of these are equal to 180. So since they're both equal to 180, we're going to get rid of the 180 and set these two pieces equal to each other. So measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. And anytime we do that, we're basically just taking this and putting it in here, so that is substitution. The reason I did it in that order instead of this is equal to this was simply because of what we were trying to prove. We are trying to prove the measure of angle 1 equals the measure of angle 3 plus the measure of angle 4. So when I line it up this way, the 1 is on the left side and the 3 and the 4 are on the right side. Otherwise, I would have to use a symmetric step to flip it over, and that would add another step. But if we're doing substitution, you can set either one first and either one you want second. So this made the most sense. Now when we look at this, we can see that there's a measure of angle 2 on the left side and a measure of angle 2 on the right side that is not in the final statement here, the proof. So what we want to do is state our reflexive step so that we can take these away. And when we take them away, this is what we're left with, step 5. I'll put the reason up here just so it doesn't bombard my angles here. So all we did was subtract to move those away. So we have proven that angle 1 is always equal to measure of angle 3 plus the measure of angle 4, which is actually called the exterior angles theorem, which we will talk about later on this year. Moving on down to the last example on these notes, number 6. We have a couple wordy statements. So as soon as we get our given in here, ray EB bisects angle AEC, and angle 1 is congruent to angle 3. We can work backwards and do our wordy statements. EC bisects angle BED. Now remember, we only mark the given in the picture. So if EB is the angle bisector of AEC, then these two should be congruent. Now according to our We the People Eat Pizza, we want to undo our wordy statements first, but that is up to you. However, let's look ahead. So let's go ahead and do this wordy statement and see where it gets to us. So we marked this, angle 1 is congruent to angle 2. This is of course our given. This is a wordy statement, which we know all wordy statements when we translate them. That's going to be definition of an angle bisector. So there's a wordy statement there. Now let's work backwards Now when we work backwards, we don't mark anything in the diagram, but we can undo this wordy statement just like we undid this wordy statement. So if we look at the diagram, if EC bisects BED, if we want to prove that EC bisects BED, we have to somehow prove angle 2 is congruent to angle 3. Again, we don't mark it in here because that's part of our proof. We can say angle 2 is congruent to angle 3. And again, at the end of the link is where you put your reason. We're not linking those two, but the wordy statement with that. And then here, when we link these two together, the reason goes here. Definition of angle bisector. All right, now, once we have done our wordy statements, we want to look at what's going on here. Angle 1 is congruent to angle 3. Angle 1 is congruent to angle 2. And we want to say angle 2 is congruent to angle 3. Now, sometimes we have to convert to equality, but there's one time when we do not have to convert to equality, and that's if we want to use transitive. Now, these are incongruents, and they do have a common angle, which is angle 1. So we actually can use transitive property to reach across this link to say 2 and 3 are congruent. So step 3 is going to be transitive. And step 4 is the definition of the angle bisector. So we actually aren't going to use any of this in here, but we didn't know that when we started, so it's not a big deal. Okay, this one only takes 4 steps.